So welcome student friends to this lectures on digital techniques or digital electronics. So just to continue the last lecture where we are now discussing or trying to solve some problems of K-map technique, reduction of a given expression using K-map technique. In the last lecture we have seen few examples for 3 variable K-map and some different cases, right? How a group can be formed, group of ones or zeros can be formed. Now in this we are going to look for 4 variable K-map, right? And we'll try to analyze some different cases, some special cases we can say, that just try to understand how groups can be formed and then how the given expression can be reduced with help of K-map technique. Okay, so let's try start with this example. So since in the question it is given f of a, b, c, d, this becomes a 4 variable K-map for us, and then this is SOP again. Okay, now 4, 6, 12 and 14, these numbers are given. So just to have a comparison, if I am to write this expression in terms of this lengthy expression and then try to reduce. Okay, so 4 means 0, 1, 0, 0, 6 means 0, 1, 1, 0, 12 means 1, 1, 0, 0, 14 means 1, 1, 1, 0. So this becomes a bar, b, c bar, d bar plus a bar, b, c, d bar plus a, b, c bar, d bar plus a, b, c, d bar. Okay, and then try to find out the common terms, and using all those Boolean algebra laws, just try to reduce that. Okay, on the other hand, if you try to reduce with help of K-map, let's now see how we can reduce this expression with help of K-map. Okay, so considering this 4 variable K-map, okay, so just you can recall the structure of this 4 variable K-map. We have taken AB here and CD here. Now since we have 2 variables at both sides, the pattern would be this way: 0, 0, 0, 1, 1, 1, 1, 0. Same is the case here. Okay, so here it becomes A bar, B bar, A bar, B, AB and A, B bar. Similarly here it becomes C bar, D bar, C bar, D, C, D and C, D bar. Okay, so since AB is at upper side, so this becomes 0, this cell is 0, 1, 2, 3 and it goes on this way. Okay, so 4, 0, 1, 2, 3, 4, 5, then we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Other all are 0. So this way the mapping of this expression into this K-map I have done. Okay, now since it is SOP, we need to look for this binary 1 here. Now you can see these cells are adjacent to these cells, so the group formed here can be this way. Only a single group is formed here. Okay, now you could have gone for pair also. Now this is quad, since it is a group of 4, right? So this is quad. Now you would say that 2 pairs would have been formed here, right? So this one and this one. But one thing you need to understand for K-map, that maximum or bigger the group is, more the reduction of a variable is. So if you just consider single one here, which we have seen previously, then there is no reduction, right? If you take a group as a pair, then only one variable is reduced. If you take group as a chord, then two variables are reduced. And if you take a group as an octet, then three variables are reduced. So जितना बड़ा ग्रुप है उतने ऑटोमेटिक वेरिएबल्स का रिडक्शन है, एंड यू विल गेट अ सिंप्लीफाइड और रिड्यूस्ड इक्वेशन. तो इसलिए यहाँ पे इंस्टेड ऑफ पेयर्स वी हैव गॉन फॉर अ कॉर्ड, सिंगल कॉर्ड, राइट. सो दिस कैन बी रिटन डायरेक्टली y equal to, now if you see vertically it is associated with a bar b and ab. So out of this only b is constant, and if you go horizontally then it is c bar d bar and c d bar. No? Okay, so only here d bar is constant. Okay, so for this equation the reduced form is simply y equal to b d bar, and if it is asked to implement, then it's quite easy. Since this is AND gate, this is B and this is D, so this is B D. Here we have B, here we have D bar, and this is B D bar. Okay, so it is as simple as that, right? So this is one case. Here we are trying to see that how these groups is formed, and instead of pairing you can go for chord. All right, let's go for second example. So again f of a b c d here is given, so four variable, this is s o p, and the terms are given here. So let me again draw a four variable k map so as to simplify this. So this is a b C D. Okay, so this is 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Okay, so this becomes a bar b bar, a bar b, a b and a b bar. This is c bar d bar, c bar d, this is c d, this is c d bar. Okay, so just writing this one, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, since I have now understood this cell numbers, I have directly mapped this equation with help of k map, right? If you are finding it difficult, then initially just go on numbering these maps, cells. So this is 0 1 2 3 4 5 6 7, then 8 9 10 11 12 13 14 15. Okay, now you can see 1 3 5 7 13 15. Okay, so other all becomes 0. Right, now this is again some different case, that how we can form a group. Okay, so group are supposed to be formed in the form of 1 2 4 8 16. Okay, so here two chords can be formed, two chords. right? So which are they? This is one chord, okay, and this is another chord. So here these chords are overlapping, so we can absolutely have this type of case also, the overlapping groups. Now consider this as group 1 and this as group 2. So my Y is group 1 plus group 2. Now what is my group 1? Group 1 is equal to, now you can directly write the equation. Group 1, if you go this way it is B, and if you go this way it is D. Correct? Group 2 it is A bar and D, right? So my Y equal to A bar D plus B D, right? So we can again write D in bracket A bar plus B. Okay, so you can see a big equation is simply very quickly and very in simple form is reduced in this expression. Okay, and if it is asked to implement, then you can simply implement this. So we have two these gates. I'm trying to reduce this, implement this. Okay, so this is D for both. I have here A bar, I have here B, this is A, B, okay, and these are ORed. Right, so output here is A bar D and here it is B D. So this becomes A bar D plus B D. Okay, so here we have seen a group or a chord can be overlapped, and we can consider even that also, right? Okay, now going for next. Now this is very interesting case here, this example. Let's see this. So again 4 variable and SOP. So just drawing a 4 variable K map. This is A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so it is 0, 1, 2, 3, right? 4, 5, 6, 7, 8, 9, 10, 11. And we don't have anything here, 12, 13, 14, 15. Okay, so I can again number here just to make it simple. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now you can see all the corners are being caught here, other are 0. Now each corner cell is adjacent to each other corner cell, right? So the group formed here is this way. Now it's not a single one, it is a chord. It is a chord. Only one group is formed here, right? So this becomes A bar, B bar, A bar, B, A, B, A, B bar. This is C bar, D bar. This is C bar, D, C, D, and C, D bar. Okay, so chord is formed here. Now since we have only one group, So this becomes y equal to, if you go vertically, then it is associated with these two variables where b bar is constant, right? And then if you go with this horizontal, then here you can see d bar is constant. Okay, so for this expression, the final reduced expression is y equal to b bar d bar, right? One thing again, I just would like to remind you that y equal to b d whole bar, these both are different. So just you need to take care that you are writing y equal to b bar d bar, right? So this is the final equation. Okay, so here we have seen how a chord can be formed from this corner adjacent cells, right? So this is not single group, but it is a chord. All right, let's have another example here. The question is, for the logical expression given below, this one, draw the K-map and obtain simplified logical expression. Okay, so they have asked to draw the K-map and logical expression. Also implement using basic gates, right? So from the equation, one thing is clear, that this is SOP. Another thing, as the largest or highest value is 15, this becomes 4 variable K-map. 4 variable K-map. Okay, so just let me draw a 4 variable K-map here. This is AB, CD, so 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0. Okay, so this becomes A bar B bar, A bar B, AB, AB bar. This is C bar D bar, C bar D, CD, C D bar, right? So again you can simply number these cells. So this is 0 1 2 3 4 5 6 7 8 9 10 11. If anyone has doubt about numbering of these cells, then you can just watch previous 2 to 3 videos. You'll understand how this numbering has or how this numbering takes place, right? Then 12, 13, 14, 15. Okay, so I'll just replace this 1, 5, 7, 9. Okay, then 11, 13, 15. And other all are 0. Okay, now here you can see again how the groups can be formed. Okay, so this becomes one chord, right? I can say this as group 1. Then I need to go for higher group, right? So again this is group 2. Instead of going for pair, I am going for a chord. Now only one group is left. Okay, now here we can go for this pair or this pair, anything, or even you can go for this chord, group 3. Okay, so I have gone for higher groups, you can see in this. Now my y is here G1 plus G2 plus G3, since it is SOP. Now what is my G1? If you go this vertical way, then all the variables are changing here, right? All the variables are changing. So simply vertical span here is equal to 1 and horizontal equal to C bar D. So my group 1 turns out to be C bar D. Okay, then my group 2, so I can write here group 2. If you see, this is our group 2. So vertically I can go for A and horizontally it is D, right? And then if I go for group 3, this becomes B, right? Because this group is associated vertically for A bar B and AB, out of which B is constant and here again D is constant. So my final equation, y equal to C bar D plus AD plus BD. Taking D common, I can say A plus B plus C bar. But since it is SOP form, this is we can consider as a final equation. Okay, now if I am to implement, because in the question it is asked also implement using basic gates, right? So if I am to implement, I can implement in this format. Okay, so first is C bar. So C bar D, then we have A, D, then we have B, D, and all these are ORed. So Y, right? So this is how you can implement the given this expression, right? So this can be asked absolutely for 4 marks or 6 marks, because they have asked to first draw the K map, then reduce the expression, okay, and then implement using basic gates. So this becomes a 6 marks question, 2 marks each, as far as exam point of view is concerned. Okay, and then we have these examples. So you can very quickly go through this example, since it is 4 variable and SOP. So quickly draw this. This is A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so we have 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, other alls are 0. So now how you form the group here? So one is this chord, this is single, and this is pair, right? So we have group 1, then group 2, and this as group 3. Okay, so my final equation y equal to group 1 plus group 2 plus group 3. So I can directly write down group 1 becomes A bar C bar plus group 2 is A B C D, because if you go this way it is AB and if you go this way it is CD. So that's why we have discussed that if you take a single variable then no other variable is eliminated, right? And group 3 is B bar C bar D. Okay, this is our final equation for this expression. Okay, so this expression in reduced form is in this form, right? Now you can try by your own this example, right? Okay, you can go for this, and this is another example which is asked in the question paper. Winter 2019 for Diploma Engineering, Winter 2019, this question was asked for 4 marks. The question is simply minimize the given Boolean expression using K-map, right? So you can try both of these examples and let me know. Okay, so this is all about the K-map. Now, having this information of K-map, in the next lecture we'll actually go for implementing these combinational circuits, and then we'll start with adders. So just recall what were the examples which we mentioned for combinational logic circuit. The first one is adder, right? So in the next lecture we'll start discussing about these adders. Okay, till then, have a nice time. Thank you.